Hello, and welcome to Unreal Engine 5 for Architectural Visualization Intermediate level course. What makes this intermediate is the architectural representation level. And let me explain. So at level 1 we have these static images, a typical renders. These still renders, they show off your buildings and your environments clearly, but the visual information is quite limited and quite abstracted as well. At level 2, we have animations. Like a roller coaster, you're kind of put on these rails and guided through the 3D space of the design. A bit more information, and especially if you animate the daylight cycle. I've covered these two levels in Unreal Engine 5 for Architecture Beginner Edition course, and we'll talk a little bit about that later. So now, after static and then dynamic representation, we have level 3, and that's interactive. You're free to move wherever you want in the design and interact with the environment, right? So I strongly believe that this is the direction in which the whole architecture industry is heading, and I hope to give you a head start. Let's look at a short clip showing the end result of this course. Right, so a few things to note before we actually begin. First, you saw 4 key functionalities that we will be adding. The first one being able to move objects, such as doors, windows, or what have you, even chairs. Second one, being able to switch materials or shuffle through materials per object basis. Third one, being able to change the sunlight angle, that's a very important one. And fourth one, being able to change the objects themselves. And this should be enough for you to build upon and come up with your own ideas on how to develop your projects, even further. And the second thing that I want to touch upon is that I will be using this scene that we have created during the beginner course. You don't need this scene to be able to follow along, but if you want it, there is a Patreon link in the video description below. If you support the channel, you will get every model, every scene, every file that we do here for free. Now, of course, it does include this scene as well. So with this being said, I think we can jump right into it. Let's go for chapter 1, opening and closing of doors. Okay. So the first thing that we want to do when creating this kind of an interactive environment is make sure that our mode in which we're running this project is set to, well, in our case, first person character mode. And to do so, we can go to settings, project settings, right here. maps and modes, and choose or see if default game mode is set to first person game mode blueprint. If not, then there are a few things that we need to change. Let me quickly guide you through them. Well, if your game mode is not first person character, that means you probably don't have the assets and you've started with a different type of a mode to begin with, or different type of a template to begin with. So to add in this functionality, you click on add, choose add feature or content pack, and from here you choose first person and click on add to project. Once that is done, you will then see these two folders appear, or sorry, 3 folders appear, and also you will see under project settings, you might need to restart, by the way, under maps and modes, if you expand this and type in first person game mode, you will see your this game mode being available for you. So that's step number 1, making sure that your game is running in first person. You might need to restart it, by the way, for it to catch up, for it to start working. Once you've done that, then when you press play, the play button, you will be able to run around in your environment, and you can even see the hand. Let's see if we can see it in the reflection. Yeah, you can kind of see the hands in the reflections of your first person character. The hands are the only things is the only thing that you get with the first person game mode, but even those will be deleted later on. Anyway, that means this whole thing works. Now we need to introduce functionality, right? We want to open up a door, and let's start with something simple. We will not open a door. Instead, we will create a box here, and we will rotate a box, right? So to do so, first step is to actually create this kind of an interaction button, right? A button that you press to interact with objects, for instance, to open doors. Before, you used to do this through settings, through project settings, creating a new key mapping, but these days there's a new workflow, right? So to create a new interact, let's say, button, you go to your first person your first person folder right here. You go to input, and here you can see there's IMC default state and IMC weapon state, right? So these are mapping contexts, meaning that, and basically they contain actions of what a character can do in different contexts. So this is when a character is just running about, the default state, and this is when a character is holding a weapon, meaning that there's going to be more actions available to the character, such as shooting the weapon. In our case, we will not have a weapon here, so we don't care. We only care about this IMC default context. So before I jump into here and actually create a button, we need to create that action. We need to actually have an action that will be able to be called by the IMC default context. So I'll go to the actions folder here, and here we have 4 different actions that the character can currently do. It can jump, it can look, so switch the camera position, it can move, WASD, right? And it can shoot. And that belongs to the, of course, to the weapon mapping context. So we'll create one more, right? I will right click somewhere where is empty on the screen in the scene, and I'll choose input action. Click that and call it IA interact. IA interact, right? So that's going to be an action where We press a button and our character interacts with something in the environment. I'll double click it just to check. Nope, everything here is fine. We don't need to change anything here. So we have that action. Let's go back to input and open up our IMC default input mapping context, right? Like that. So you can see here that by default, the character is able to jump, to move around, and to look around, right? But it's not able to shoot because it does not have a gun, right? It is not holding a gun. And that's fine. So for us, I will add a mapping right here by clicking a plus sign, which will open up this or add this whole tab. I'll expand this and I'll find my IA interact input action, like so. And this is where you actually decide what button needs to be pressed to call for that action. So you can either choose from you know, a bunch of these menu items, or you can simply click on this keyboard icon and then press the button that you want to use. So do we do mouse click? No, let's do the typical E button. E as in eraser or Erasmus. E. Okay, like that. And with that done, actually we don't need to do anything more. We just hit save, we close it, and we're good to go. So now our character has that interact functionality, right? Which is great. We are not calling for it just yet because we need to access the character blueprint, but at least we have set everything up. Now, if I go to first person blueprints, and I click on my first person character, that is the character control blueprint, right? Basically, it has the viewport. This is how our character looks like. Hey, it is what it is. Also, I wonder why is this so weirdly placed. Capsule component. Why is this offset? Whatever. Let's not worry about those things. Those are minuscule and easy to fix. Instead, we go to our event graph right here, right? And here we will create that input action event, right? So when we press E button, something happens, because here you can also see event begin play. When the game starts, something happens. Enhance input action, IA look around, move, and jump, right? So when jump is triggered, jump, character jumps. When jump is completed, stop jumping. Easy as that, right? So let me right click and choose IA interact, right? Interact. Enhanced action event, not value, event, interact. Like that. There we go. That's our button. And we can do something very simple. So when it's triggered, we can print string that says hello, right? Let me compile and save. Press the play button. For some reason my character is outside now, doesn't matter. And just press E button. And you can see as I press the E button, hello is printed on the left hand side of the screen. That means the character, and I just escape out of there, that means the character does indeed interact with the interact action actually transfers to the character properly. Okay. Now, for this to work, we want to create, we want to know where the character is looking at. And if the character is looking at a specific like object and we press the E button, it should shoot out a ray. And if the ray hits that object should then react to it, right? So imagine as we're shooting a laser at different objects, and if we're shooting a laser at a wooden box, the first time you shoot a laser at it, it changes color from brown to black, and next time you shoot it from black to white, and so on, right? So you shuffle the colors, or it rotates. In our case, it's going to rotate. So when interact action is triggered, we actually need to call for line trace. Line trace. And let me just see. I believe it's just line trace by channel, right? Like that. Which is going to basically shoot out a line until it hits something. And we need to define the start position and the end position of the trace, you know, how long the line is, where it starts, or where it ends. So the starting position is going to be quite easy, because all we need to do is just get the camera, first person camera, from here, drag and drop it in, and we need to get its world position. Get world, or world location, sorry, like that. And that's going to be our start. That's easy. Then for our end, where it goes, we need to basically understand what's the direction of the camera. Where are we looking at? So from this we will get forward vector. Get forward vector. Okay, the forward vector is actually very small. It's 1 millimeter or 1 centimeter long. And I believe maybe it's not going to, well, we'll see. We'll see. This might not work. We might need to get the world vector from the rotation information. Let's just try. So get forward vector. It's 1 centimeter long. We need it longer than that, so let's multiply. And we don't multiply it by different numbers. We're actually going to multiply or make the vector longer uniformly. So I'm just going to right click on this input and choose to float or to integer. Let's choose to integer, like full number. And here I will just type in, let's go for 10 centimeters, 1 meter, 10 meters. Yeah, let's go for 1,000, which is 10 meters, right? So now we have our forward vector that actually starts from 0, 0, 0 coordinates. That's that we will need to fix that, but ends at or its length is 10 meters long. So how do you move a vector to start from the head, right? From the camera location? Well, you just add up two vectors. That's simple math. So we just add our world location with our forward vector, like that. Drag that one out, like so. And I think that should do it. Let's save. Let's press play. And let's press E. Oh yeah, sorry, escape. Forgot one thing. For us to actually see the line trace, we need to draw a debug type to change this to be either for duration, for one frame, or persistent. Let's go for persistent right now, so that it just stays. Compile, save, play. Now it starts inside. That's weird. And let's just shoot out a ray. See? That's a ray that was shot. I just pressed E. Let me shoot out another one. Maybe here. See? There's a ray that is being shot from where I'm looking at. And once it hits something, it turns green. I can do that again. Let's go for the table a few more times. And I can shoot a lot of them, right? I'm just pressing I was just pressing the E button a lot, right? So we're tracing where we are looking. And if I'm holding the E button, it just keeps shooting, which is not that great. I think we need to fix that one, because holding it should not trigger the line trace that much, but it seems to work, so that's good. I believe maybe if we just choose started, maybe that's going to be fine. Oops, sorry. Instead of triggered, if we go for started or ongoing. Or completed, sorry. Let's go for completed. Let's just see how that works. Press play. Hold the E button. Yeah, so now it's going to shoot out only when you release the button. Which might be a better result. Let's try the last one. I promise, last one, and then we'll move on. We've started. Yeah, started is the best. Okay, started basically triggers it once when you click the E key, and it does not keep tracing multiple line traces by you just holding the E key. Either way, now we have a working method of how to check what the character is looking at and what it's shooting at, right? So now we need like an interactive object somewhere here, and if we are looking at that object, the character or if the character looks at that object and we press the E button, the object will rotate, will spin. How do you do that? Well, you go to your content folder, the main content folder, and you create a new folder in it. Call it blueprint or blueprints. And here I will create one more folder and call it like interactive move. Double click there, and we just create a new blueprint class. And I'll make it actor and call it test box. Test box should be fine. Double click, and inside of the test box, we'll add a cube, just like that. There we go. We have ourselves a little cube. Then this cube right here, we will need to let's think. Every time you hit the cube, it needs there needs to be something that triggers here. How do you do that? Well, actually, you need one more blueprint. So let me compile the test box, close it, or not close it, I'll just dock it in here, and let me go to my main project and go back to blueprints folder. And here I will just create a new blueprint, but it's not going to be like a blueprint class, rather under, I think it's under blueprints. Yes, blueprint interface. Think of it as a bucket which gets filled with information if something happens. So you use it to transfer information from one blueprint to the other. And thus, we will transfer the information from our first person character blueprint into our test box. And that information is going to be, yo, I just triggered you with the, by shooting at you, right? So we'll use blueprint interface like that. I'll just call it BP interaction, blueprint interaction, and we don't need to do anything with it. It just needs to exist, right? That's all, blueprint interface. Then in our, apologies, in our test box, we want to be able to call for that blueprint interaction asking, yo, do you have something for me, right? From this blueprint. So how do you do that? Well, you go to class settings right here, And under Implemented Interfaces tab, you click on Add and you find your BP underscore interaction. BP interaction. Like that. You compile, you save, and if you were to look at... Where is it? Are we not calling for it? Maybe it's fine. So once you have it implemented, right? You right click and you choose interaction. Let's take a look. It's not being called. What's going on? That's weird. Compile and save. Okay, sorry. So what was weird was that this was not compiled. So you do need to open it up until at least once, and by this I mean the BP interaction blueprint interface. You need to open it up at least once, compile it, save it, close it, never look at it ever again. And then once you implement the interface, you will see under interfaces, new function has appeared. If you don't like the name new function, you can always go back in here, open up your interaction blueprint interface, and here under functions you can change the name. So for instance, I can just say interact interface like that. Compile, save, close. And here you can see now in my test box blueprint, the interact interface is, the interface that we're using. Okay, so now to actually have it in here in the event graph, you right click and you choose interact interface. And it needs to be add event interact interface, like that. And basically every time that blueprint gets triggered, blueprint interface gets triggered, this interact interface will get triggered, and then you can say, yeah, just rotate. Or in our case, we will again use print string. For now, we're just going to print hello from our box. Compile and save. Go back to your first person character blueprint. Yeah. And here, when we hit, let's say, a box, then we will need to, when we hit a box with array, then it needs to transfer the fact that the box was hidden into the box through the interact blueprint, right? So to do so, I'm just going to create a branch right here, and I'm going to say if hit was done, so if this returns true, then something happens, right? Then I send the interact. If it's false, then I don't send anything, right? So that's the first thing. Then from here we can call, let me check, interact. Yeah, we can call for interact interface as a message. So we send it as a message that, yo, you're being triggered to the box. Okay, and now it asks me, okay, where do you send this message? Who do you send this message to? And this is where our test box blueprint needs to go. How do we know that we're hitting the test box blueprint? Well, we can just get it from here, from output of the hit results, right? So that's a structure, meaning that we can break it. Break, I'm writing break hit result, and let's just expand it like that. And from it, let's fish out hit actor, this one right here, hit actor, and connect that to target, right? So let me break this down to you. You press E right here it shoots out a line from your eyes, from your camera into anything that you're looking at for 10 meters straight, right? 10 meters. It shoots out this ray, and whatever it hits, it's trying to send a message to that you are being hit, right? And if it hits a box, since the box has a message receiver, the message receiver will trigger, and the box is going to say hello to us, right? That's the plan. So let's compile and save the character. Let's actually, don't forget to put in the box, right, into your level, like that. Let's press play. Why? Oh, we have like a player start here, that's why. Okay, let me delete the player start. And let's press play now. There we go. And we can just look at that box, and if I press E, it says hello to us. It says hello to us. If I press E somewhere else, it says nothing. Box says hello. Nice, huh? Okay. So that means this is triggering, this is working. Okay. That's not enough. It needs to actually rotate, right? So I'm going to say if we trigger this, we play an animation of the box rotating. And to do so, you use a timeline, add timeline, use a timeline that basically can have, let's call it box timeline. I misspelled it, that's fine. And you can double click on it to change its properties, and we will. So we open it up, and here in our box timeline, we add a track, like that. And we add float track. Okay, and we can call this track box track. You know, box animation track or whatever you want. Okay, with that done, we need to specify here how long that animation is going to play. So I'm going to say 1.5 seconds, something like that. Then we need to add in 2 key points, one at 0. You right click on the curve, this line curve, and add key, right? And here, when you have the key selected, you can just type in a time. So add 0, the value needs to be 0. And then you can add another key. Doesn't matter where you add it. Because here, then you type in at time 1.5, the value needs to be 1 or 90. I prefer to always use values between 0 and 1 and then do the math later outside in the event graph. If you want to, you can just use value of 90 degrees, you know, or whatever. I'll use 1, like that. You can press these 2 buttons, zoom to fit horizontal, zoom to fit vertical, to see both points, and then you can right click on them, on these points, and choose auto. So it basically will smooth the transition, auto as well. It will smooth the transition of opening and closing, right? So it's going to slowly start, then ramp up, and then close slower. Okay, let's compile, or not compile. You can compile, but let's go back to the event graph because this is good. This is working. And in the event graph, how do you work with this? Well, we need to add the rotation to our cube. So local transform, get local transform, no, add local transform to the cube, just like that. Actually, we can just add local rotation, right? 1 second, I'm going to find the best variant of this, and then we'll teach you that. 1 second. Okay, I'm back. So what we need to use is, I believe set relative rotation. That's the best one. So we can do set relative rotation, and in this case we will use it for a cube. Later we'll make it a little bit nicer, but for now let's set relative rotation cube, like that. So when it updates, it goes into, it triggers the rotation, and the new relative rotation needs to be broken apart. So we can say make rotator, like that. And basically here we just need to decide what's the new X, Y, Z rotation. We don't mess with X, we don't mess with Y, but we will mess with Z, of course, right? That's because that's our the yaw, the door yaw, and so on. Most of the things in architecture rotate around Z axis, right? So that's what we're going to be using. We basically have that track that is going to be spitting out the info for us. So all we need to do is, and the info is going to be between 0 and 90, 0 and 1. So we just need to take this and multiply that by 90 degrees, right? So we control the degrees through this number right here, and that connects to Z yaw. Should be enough for us to, this should be enough for us to check if this is gonna work or not. Don't forget to compile and save, and then press play. Like that, press E. Yay, rotates. And next time I press E, it does not rotate anymore, right? Because it's constantly trying to set, it's setting it to 90 degrees rotation, and it's not setting it back, right? So it's not going to keep on rotating or anything like that. We need to actually be able to, the next time I press it, it needs to rotate back, right? So we open the door and then we close the door. And to do so, I'm just going to ask, how do we ask? I can ask if the door is open or not, right? So the door always starts closed, right? So I can do this. Under variables, let's create a new variable and call it is door open, right? Is door open. That's a variable, and it's a boolean. It's true or false. Yes, the door is open. False, the door is closed, right? So we get is door open, and actually here we can choose, we can compile, don't forget to compile, and then is door open. If this is not tick mark, that means it's closed, right? So that's the default value. That means we start with the door being closed, and with this, yes, it is closed, we can use a gate or a branch or gate. Wait, I keep forgetting. Branch is like that. Yeah, we use a branch, right? We use a branch where we say that if the door is not open, if it's closed, then it needs to open, right? So false goes into play, right? The door is not open, it's false, so you open it. But if the door is opened, if yes, then you close it. So you play the animation in reverse, like that. Yeah, something like this should be fine. Okay, and now we need to check we need to change the door's not position, but the state of the door from closed to open the moment we open it up, right? So every time when we get a box, when we get box tracking, I can ask, yo, are you greater than 0.1 or something like that? Like something very 0.01. It can actually be greater than 0. If it's greater than 0, if this number, because we're playing it, right? If it's greater than 0, then that means there's at least a little bit of rotation going on with the door, meaning that it's not closed, right? So if it is greater than 0, then this set needs to be closed, right? This door, yes, it is greater than 0, so is door open becomes true, right? The door becomes open. And we actually need to evaluate this not every time we press the E button, but at every tick of the game. So I'm going to use this event tick. You can create your own if you want to, you know, tick, event tick right here. But basically you just use that and you connect it to is door open. So you check at every instance of the game. And this should be enough for us to interact with any object, in this case a cube, but later a door. Okay, let's take a gander, let's take a look, let's press play. Compile and save, by the way, and then press play. E, okay, E rotates back, E rotates forward, E rotates back. I shoot somewhere else, does not react, I shoot at it, E, E, perfect. Works like a charm. Wonderful. Okay, so that's done. Now all we need to do is just replace the box with an actual geometry of the door. And also, instead of this ugly ass line trace, debugger, we want to have like a proper, like a nice little indication. I still want to keep it minimal, but I want it to be, you know, cozy, nice and neat. So what I did was let me open up and show you. I created this, I hope that it's gonna open up properly. Let me try here. Yeah, there we go. I created this paw image, icon, whatever have you, and every time when we shoot at an object or anywhere, it's going to put this cat paw on top of the object. I think that's a good minimal interference type of a user feedback or user interface of where you're actually shooting at. So to import the paw, we actually go to materials, because we already have our materials tab, and under textures I can just simply drag and drop it in. Boop. And there's my image. That's the same PNG that I showed you. It does not have a background and it's just a black image of a paw, right? Then I need to create a material. So under materials, I'll create a new one, and that is going to be my paw material, right? So basically we just create a new one, material, there we go, and call it paw decal or decal. I still don't know how to pronounce that. Let's go for decal. Like that. Double click on it here. Perfect. And here I basically want to, this decal material, I want to change a few things. So the first one is the blending mode. From opaque, I will go for translucent. Or is it masked? I don't remember. I think it's translucent. And then here we don't really need to change anything else. We don't change it to no, we don't change this to decal or decal. We keep it as a surface. Then for the base color, we will use a texture sample, for which we will choose our paw texture, paw, like that. Connect. There we go. Then we have our opacity control right here, where we can actually just use the alpha channel of our texture, because it's a PNG, it's transparent, and just slap it into the opacity channel. And thus we get a paw. I mean, it's now being shown in a weird way. Let's show it on a cube, and you can see there's our little paw right there. There's not a lot of information here that we can use extra. Well, we can have emissive color, but let's not do that. Instead, I believe maybe, okay, material domain, let's not use a surface. Let's use a decal or deferred decal option right here, because that gives us metallic and it gives us roughness and so on. Because I want to introduce a little bit of roughness, I'll just hold 1 on my keyboard and click. Wait, 1 here. Stopped working. Okay, cool. I'll just type in scalar parameter, like that. Call it the roughness, and just connect that to my roughness input here and change its roughness to 0.5. So that's a little bit more shiny, you know, a little bit more glossy. Easy as that. And then for opacity, I perhaps want the little foot here to be also a little bit transparent. So I will remove from the alpha, I will subtract, let's go for 0.2, something like that. So here you can't really see that. Well, maybe here you can see that it became a little bit more transparent. You'll clearly see it once it's used in game. Okay, that's done. That's our material, and we will shoot it at different surfaces every time we do a line trace. So now how do you, okay, with this done, how do you actually shoot it out? Well, after in our first person character blueprint, after we have sent an information that, yo, we interact with you or whatever, we can also create a decal or decal at that location, that exact location where we shot it. So I'm just going to spawn decal at location, like that. The material is going to be our newly created paw decal material, the size, well, I need to choose the size. How big is a cat paw? Actually, let's do it bigger right now, just so that we can see it better. But 5 centimeters, it's probably smaller. No, it's probably bigger. Is it bigger or smaller? Where's my ruler? No, 5 is big for a cat. Well, it is what it is. We'll have it 5 centimeters. It's a large cat, okay? And then for location, that's easy because we are hitting an object and we're getting a location where the object is being hit. Wonderful. We just yoink, just connect location to location. And then for our rotation, for now I will not change anything with the rotation because I still I need to see if it's working or not. So I'm just going to compile, save, press play, and just shoot at the floor. Yay! A bunch of cat paws are being created. We're happy. We are happy. Okay. The problem, okay, actually let me show you the problem with it right now. Well, that's not a problem, that's fine. It's just basically, yeah, it works on the, for instance, the ceiling, that works just fine. it does not work properly on a wall. So if I shoot on the wall, you can see that it's just a blur, and that's because it does not change its rotation according to the angle of the surface at which we are shooting, right? So we need to fix that. So under our first person character, under the rotation, we need to actually get a normal vector, right? So normal vector is like 90 degrees angle from the surface which we hit. We need to create a rotation from x vector, like that. So we create a rotation from x vector. We... wait, what if we just do that? I think that might work. Rotate, we get a rotation, we put it in. Let's press play and just see. Okay, so paw is created there, that's fine. What about here? Yay! And here? Yay! Okay, so it does create paws. A little problem is the fact that all of them are always rotated at the same angle. That's boring. That we don't want that. So we want to create a little bit of randomness, right, in terms of like placement of the paw. And to do so, all you need to do is just this rotation, we need to add up a little bit of randomness to it, right? So we break rotator. Is it into axis? I think it's just break rotator. We get the roll, the pitch, and the yaw, right? So we don't mess with the pitch and the yaw, we just mess with the roll, right? Because that's this motion, what I'm showing here. That's the roll, that's the pitch, and if that's the pitch and that's the roll, oh, that's the yaw. That's the yaw, of course. Okay, so we make rotator. We connect pitch and yaw just as it is, but for roll, we will create a random float. Random float. And the random float, it's basically a random number in between 0 and 1, right? So every time we press, it gives us a new number. So we just multiply it by 360 degrees. And then connect it to the X. And that's our new rotation. And this should work like a charm. Compile. Actually, let's stop looking at the debug type or line trace debug. So none. We don't need to see it anymore. Compile, save, look at the building. Okay, that's good. What about here? Yep, those are feet. Little cat feet. Poop, 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 poop. Okay, so you can, congratulations. Those of you who played Counter-Strike now are able to create sprays in the map, right? But that's not what we want to do. So we want the little cat feet to disappear after some time. And that is very easy to do. That's the lifespan right here. So for the lifespan, let's use something like like 2 seconds, something like that. Compile, save, try again. Boop, 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 boop. There we go. That works. Okay. Boop, boop. Okay. So that's done. That is done. We are happy. Now it's time to finally make, let's say, this door open up, right? So to do so, we need to, well, first of all, let's save and let's close the material. Let's close the first person character blueprint. We don't need that anymore. And let's close the test box blueprint as well. Let's go back in here to our blueprints, interactive move, and let's just make a copy of our test box. And that copy is going to hold the door. Yeah. So to do so, right click, duplicate, call it door BP, door blueprint, and then open it up, right? So that's your door blueprint. Let me make it smaller or bigger like that so that things fit, and let's just delete the cube from it. Just like that. Okay. Now the door blueprint is going to be kind of weird, and that's because we will need to how do I explain this? So stuff that comes from Datasmith, right? From the Datasmith library, usually gets reoriented in a weird way. So in this case, for instance, if I select the door, you can see that it's 348, minus 329, and 117, right? In terms of its alignment in the world. And if you want like a perfectly precise alignment, then you would need to work with these numbers. I personally don't suggest you do that. It's much better to fit it by the eye as close as possible. And that's what we're going to be kind of doing, honestly. So basically what I'm saying is we're going to lose a little bit of this kind of perfect seamless connection to get it going, right? To make it a little bit more user friendly, or else it's gonna be a lot of math, a lot of numbers, and we're not nerds. We don't do that thing here, do we? Okay, so that door that we have here, let me move myself to here like that. So we just select the object that we will want to rotate, and actually 3 objects because handles are also going to be a thing. And I'm just going to click on this browse to brep 36 whatever on my how is it called, details tab, in the details tab when I have the door slab selected like that. And it gives me this brep 326, perfect. And I just, under viewport, I will just drag it in. brep 326, bam. That's here now. Right? Let me just check one thing. Yeah, okay, that's fine. So brep 326 is now located right here. And I can move it anywhere I want and then position it any way I want, but for now let's leave it be. Let's leave it at 0, 0, 0. Then we have our handle, and the handle is going to be also, we browse to it and we not copy it, we move it in here, right? And that it can be connected to our door. That's fine. If you don't want it to be connected, you can have it, you can just drag it onto the default scene route and just attach it there. It doesn't really matter where it is, right? So now with this done, I basically need this handle to be placed in the, kind of the same position as the door is, right? And I can see that the door 17, 1 second, 98. Okay, so the handle is placed like a meter above the ground level, right? And here in this case, the handle, where is it? It's at 0 centimeters from the ground level. So all I need to do is just add 100 to it, and this is going to be the correct height for the handle. As for the door, I kind of need to, oh yeah, I forgot that the handle is connected to the door, so that's kind of stupid. So I actually need to first move the door up like that, and only then will I get to position the handle. Well, it is what it is. Something like this. You will be able to make adjustments as you please later down the line, right? Okay, so I have the door and now back to the handle, and the handle is at 100, and actually now I need it to be at 0, and let's just, with the move tool, let's position it so that it's nicely placed. Something like that. Is it fine? F to zoom in, near clipping, set near clip plane, the command. Set near clip plane, like let's do 1 centimeter, so 1, enter. The set near clip plane command in the console enables you to zoom into objects much closer and to get much more precise alignment with things. Okay, something like that should work. Seems good. And I'm just going to make a duplicate of this handle. So 28. There we go. And I'll just, I could just rotate it, but I think we can just scale it by -1. Ah, it does that, huh? Oh, never mind, sorry. If we unlock the scale, we can just scale it here by -1, and it gets mirrored to the opposite side. And we just position it right here. Something like this. Okay. Then in terms of the materials, we just kind of borrow the same materials. Oak veneer for the door. Oak veneer. And for the handles, that's gonna be, I guess, like black metal or something. Scratched painted steel. Okay. So I just holding shift, or no, never mind. Holding shift here, I select both of the handles, and here I just choose metal black, no, not black, scratched painted steel. There we go. And we'll adjust, as I said before, we'll adjust the handles accordingly a little bit later down the line. Let's compile. Oh yeah, compilation will hurt, and it's going to complain simply because the event graph, the set relative location or rotation, will not understand what is it that you're trying to rotate, because it does not have anything to rotate. So actually, before we let's delete that one, delete the set relative rotation, and we'll create a new one, but then compile will work. So before we can properly compile, I need to create one last bit, and that is going to be the hinge. The hinge along which, or around which, the door rotates. So under components, I will add, and I will add, where is it? Not box collision, not sphere collision, actor. No, not an actor, component. Okay, let's quickly find what we want to add. Maybe we can just add a scene. So if I create a scene here, like that, and then just move it to where the hinge should be, I should be able to simply rotate the whole thing, because here for default scene root, I don't want to mess with that, because that is going to be where my anchoring is going to be for the placement of this object. But the hinge of rotating, that should be the scene, right? And then I just simply place it next to the door around where I want it to rotate. Again, if you want to have this super precise, then you would need to do some math to find where, you know, where these points are according to the thickness of the door and so on. But in my case, I don't really care. So I'm just using the values like by eye, right? And once that is done, I simply just select all of my objects here and just drag them onto the scene, right? So now, if I were to move my, why is that? Oh yeah, sorry, and these need to go in here. Now they messed up, of course. Like that, and then just place them back again here. Okay, so a little bit janky, but it is what it is. But now we have our scene, our hinge, and if I were to rotate it 90 degrees, it opens up, and if I rotate it back, it closes off, right? So that works. We compile, then we can go to event graph and actually create movement or set relative rotation to the scene, to this guy right here, because everything inside of it will follow, right? Like that. Like that. When it updates, it sets. Don't forget that wire, that's important. And then the value is here. Compile, save that just in case. Let's go into content, blueprints, slap in the door. I can already see that the handles are too high. That's fine, we will adjust it. Let's press play. Wait for the camera brightness to kick in. There we go. And then that opens and that closes. Great. Now we just need to put this door into this location, but before we do so, I will adjust the height of the handles. So how big? It's like 20 centimeters or 10 centimeters, right? So under these both handles, I just select them, and their height seems to be multiple, set to be at multiple different heights, which is weird because I can swear that I set them properly. So let's set them to 0. And then if I mess with it, it just needs to go to -15 or something. Compile, save, look at it, even more, -18, save. That's too much. It was actually -17. Okay. And probably something like that. Okay. Now, I will just simply delete actor is referenced by other actors and objects. Yes, we do delete though. Yes. And this one too. And then we put in the new door. Slowly, carefully, neatly. Think of it this way, for those of you who are currently OCDing, think of it this way. There's not a single thing in reality that has maybe 0.5 that does not have a seam. Everything has a seam, right? Let's press play. Come on. Kick in, kick in. There we go. E. Welcome. I don't fit. Why don't I fit? I'll need to fix that. That's fine though. But the door does seem to work quite well. Actually, let me just check player collision. Yeah, that seems fine actually. So what about visibility collision? That's also fine. Okay, so it's the problem is with the player width. If you want to change the first person blueprints, if you want to change the collisions of your character, this in particular, you just select the capsule and you just change the capsule radius from 55 to something a little bit more normal, like 40. 40 means it's not 40. 40 means it's 80 in the diameter, right? So we press play. Come on. Kick in. E. And now we should be able to... Oh, we still can't get through. Is it because of the door? Let's try like that. Open. Okay. So it's not like the collision is not a problem. It's just the... Yeah, so the collision is the geometry is not a problem. It's the problem was the character being too wide. So I just changed it to like very thin boy, 20. Right. In terms of the arms, you don't probably need the arms here. So where you have the first person mesh right here, these arms, you can just simply get rid of them, delete, compile, save. Now your character will not have visible arms that you can see in the reflections, right? So that works. Okay, so now we're done with creating a door, right? And I can actually now do this because I know that these doors are the same. Except for that door right there. That door opens up to the other side, and I'll show you how you can quickly change up this blueprint to open to have a hinge on the opposite side, right? So here I just position the doors really quickly. That's not good enough. A little bit better. Come on. Holding down the Alt key, you're able to clone the blueprints or any object whatsoever. Holding down the Alt key and moving the objects, you're able to clone them. And this is actually, I can talk about this as well. See how this is just black now, and if I look around, now the light kicks in again. This is due to Lumen not liking the fact that all of this is a single mesh that has a lot of concave corners. So it's unable to calculate the light properly, which is fine. We will not make this mistake anymore. So if you want your files to be the best, to have the best possible render quality, then make sure that your lumen, not lumen, sorry, that your geometry is all split up into labs, into these kind of separate entities that doesn't have nooks and crannies and does not bend too much, right? So finite elements. Anyway, so with this door right here, that is opposite, that is different, I will just simply create blueprints, interactive move, and I'll just duplicate this door and I'll call it door BP opposite. Door BP opposite. Drop it in here, right? And all I need to do, I believe, is just inside of the blueprint, change the scene to have a scale of along the y-axis of -1, like that, right? Because we're flipping it over, right? And we just save. Do we need to compile? We don't even need to compile, or do we? Nope. And then here we can delete this door altogether. Come on. Select this one, move it in place. Boop, boop, like that. Just make sure that everything kind of fits nicely. I think that's good. Yeah, that should be good. Okay, we're done. Now we can save and test it out. Come on, kick in. Light. Okay, and then ta-da, opens up to the wrong side. It is what it is. If you want it to open up, actually it does need to open up outwards, right? Because here we have the whole cabinet, or not cabinet, like wardrobe. So it does need to open up outwards. So that actually works for us. Okay, that lumen in that corner really does not like us, but every other corner lumen kind of works quite nicely. Okay, let's check out this. Yep, that corner of the house is a no-go. Anyway, that's us done with the doors. We can now move on. And by the way, in terms of this, you can use this exact like variations of this for windows, for desks that are folding, for any sort of thing. So it's multiple things that you can do with it, and it's up to you to decide which ones you want. Okay, let's move on to the next one, which is going to be switching of the materials. So chapter 2, switching of materials. All right, so in terms of the material control, it's going to be pretty damn simple because we already have created our whole user interface. When we start playing the game, we already are capable of line tracing and making sure that the character is able to interact with different objects, right? So actually creating a material change is going to be easy peasy. So under blueprints, let's create a new blueprint or new folder. First of all, new folder, and call it interactive materials, like that. And inside of it, let's create a blueprint class, actor, and just call it for now, let's work on the floor, right? So floor BP, floor blueprint. There we go. So our floor blueprint will have this brep 513 in it. Okay. So under floor BP, actually we can close the door blueprint, first person character blueprint, and another door blueprint. Under here, we can just simply add the parquet, whatever it's called, um, we can add the brep 513, which is our floor geometry, right? So I will just simply select it, click on this browse to brep 513. It shows it to me in the content browser. I drag it over to my default scene root, and here it is. So with things that we create in CAD software and import them through the Datasmith plugin, the positions of things are usually anchored to two things. First one is the geometry itself. So brep 513 has X, Y, and Z location. And also there is the base model, the starting, so the whole scene that you import, the whole Datasmith scene, also has its own location. But in this case, the base model in our scene is at 0, 0, 0, which is very, very good. So all we need to do to know for a fact that this blueprint is going to be placed correctly is take brep 513, so our floor geometry selected, and copy the X, Y, Z location into our blueprints brep 513. So location X, Control C, to location X, Control V. Location Y to location Y, and Z is 0, so we're happy with that. So now, once we create this blueprint, or once we drag this blueprint into the scene, as long as the blueprint's position is set to 0, 0, 0, it's going to be, the floor is going to be located, on here. If you want it to be even more flexible, then I can show you. You can just simply anchor it to this base model actor right here, and then if you move the whole scene, the floor will follow along perfectly fine. Okay, also I want the material for it, so it's gonna be chevron tiles. There we go, or parquet, chevron parquet. Click save, and for now I can actually dock it here. All right, so now with this floor still selected, I'll just delete it. Hit delete. Not in here, by the way. Don't delete it in the content browser. Delete it only in the viewport. Delete, yes. And now we don't have anything here. Oh, that's the bottom of the floor. Yeah. So we don't have anything here. Then under blueprints, interactive materials, we have our floor blueprint. I just drag it in, just like so. I zero it out. So the location is 0, 0, 0. And you can see it fits perfectly, right? So that's what we're dealing with here. And then if you want to, if you change the base model position and you want your floor blueprint to follow along the base model, you would just need to drag it. Why can't I drag it? 1 second. Make it smaller and then drag it. Yeah, and then I can drag my floor blueprint into the base model, so that if then I move my base model around, you can see that the floor is moving with it, right? I will not be doing that though. Let's go back to lit preview. Okay, so that was easy, right? That was easy. So now this is a blueprint instead of static geometry, meaning that we can mess with it, right? So back in the blueprint, under event graph, I can just simply set material of brep 513, which is my floor, like that. And I can say that every time, actually, let's delete these 3 events, we don't need them. Every time I interact with the floor, every time I press E looking at the floor, it should change its material. Easy as that, right? Or you could have a dedicated key for it, but for that you would need a few more actions, which is whatever. So instead we just use this. So set material needs to be triggered by interact event, right? If you don't understand what I mean, I suggest watching chapter 1 because we created the whole damn system in there. That's why chapter 1 is so long and this one is gonna be so short. So under class settings, under implemented interfaces, I add and I find my interaction interface, BP interaction. There we go. Compile. Maybe save, I don't remember, but just in case, compile save. Right click and then you just can call for interact interface. Not function, but rather event. Interact interface. There we go. And then we just connect it like so to set material, and we can choose a material that is funky. Let's find the funky material for us to work with. So under mega scans, surfaces, can I have something? Yeah, let's go for brass. Why not? So brass. And I just drag it over here to set material. You can also search for it here if you want to, but I just drag it over. Okay, we compile, we save, and it's time to play, to see. Minimize that, of course. So again, doors are able to be opened up. And what about the floor? Bam! Now it's brass. Cool, huh? And we can't switch it back, unfortunately. So to switch it back, we need to introduce more functionality. Back in our blueprint, I can just say that we will be shuffling through multiple materials by using gate, multi-gate, like that. I will say that it's going to be looped, and every time we trigger and interact, it's going to spit out through a different wire. So output 0 first time, output 1 second time, add pin, output 2 third time, and so on. And then I just copy and paste set material for every time, right? Like that. And say that, okay, so my base material is brass, and then my next material is gonna be, let's find a nice one. Is there like a nice one? I don't want to take away too long. Travertine marble, sure. Sure, let's go for marble, maybe. Is there like a nicer one though? Yeah, fine. Let's do marble. So this is gonna be marble, and or seashell is marble. That's a little bit better, marble. And this one is going to be the back to our chevron walnut. Okay, compile, save. Since it's looped, it's going to keep on going through these. Let's press play. Boop. Boop. Nice, neat, and white. Boop. And we just keep going, right? Cool. That works. All right. With this done, I think we can, I mean, I can show you one more. We can work on furniture, I guess, to be able to change the furniture. I'll just repeat it real quick just to show you that it can be done. Or do we want to do furniture? It's all the same. Maybe stay away from the furniture. Instead, let's do let's do this niche right here with 2 objects rather than 1. Yeah, that's gonna be good. So back in where we have our blueprints, materials, let's just duplicate the floor and call it niche BP, because that's the niche. Open it up and let's just like that. And for the niche blueprint, let's just find the geometries that we need to use. So that's gonna be brep 1126. That didn't drag over. Oh yeah, it won't, because we need to browse to it and then fish it out from this menu and then drag it over. Okay, and then the bottom one, the bottom little box here, that's gonna be extrusion 106, and move it in here. So and then 513, which is our floor, is unnecessary, right? So we delete it. And both of these have a material of travertine marble at the start, so I just use that, right, for both of them, just like so. Don't forget, never forget the placement, the placement of these geometries, right? So what you want is, for the extrusion, you want X, Y, Z to match up with the already existing coordinates of the objects in the scene, or else things will be misaligned and bad, and you'll have a bad time trying to figure out what the hell is going on. And also for brep 1126. There we go. Now it's all neat and dandy. Compile does not compile. Why doesn't it compile? That's because under event graph, we have deleted the floor, so it does not have a target. How do we make it have a target again? Well, we just take the 2 extrusions and extrusion and brep with the shift key and just drag them over here and just connect brep, 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 extrusion, 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 like that. So both of them connect to all 3 set materials, right? You can do, you can set for separate objects, set separate materials if you want to. I can show you, for instance, here. Let's say, let's disconnect from the last one, and the last one, brep, will have the chevron tiles or material number 3, while extrusion, we do another set material like that, and the extrusion will actually, let's make it cleaner like that. So brep will have one type of material, while this one will have like steel or something, brushed steel, sure, right? So that's how you make them separate. And I believe the second one, or let's do the 4th one, should be still the travertine marble, of course, right? So we again set material, doesn't matter to which, because I'll just grab the other one and connect that as well, and that's gonna be travertine, like that. Yep, should be good. Compile, save, close, and actually replace the existing geometry. So delete, blueprints, materials, niche, and we just zero it out like that. And when we zero out the position of the niche, it of course automatically just snaps in place, snaps in place, just like that. We're happy with this. We press play. E, E, E. And you can see that this one is different, like 2 different materials are attached. So for instance, for the chair, that would be exactly the same procedure. You would have one material for the leather and the second material for all of the wooden pieces, right? There we go. Slowly making everything gold. All right. So with this done, we can now move on to transforming the objects, right? To making the objects different. So for instance, what's a good example? What are we gonna be working on? Like a banana or something, right? Making the banana work. Yeah, let's go for transforming a banana into something else. So that's gonna be the next one. Alrighty then, so let's change up some objects. So in terms of changing the objects or changing the materials, the workflow is very similar. All you need to do is replace an existing object with a blueprint or with that object, and then instead of setting the material, you set the static mesh. Let's do that. So let me just create a new folder in our blueprints folder, call it interactive objects. And there's going to be a little bit more to it, so don't just skip ahead, listen up. So under interactive objects, I'm just going to create a new blueprint class, actor, and call it, I don't know, a Chimera object or object BP, object BP. Let's call it that. Here under, here under object blueprint, that we need to add a few, at least one static mesh object, right? So I'm going to say, let's right click here, or sorry, let's click on add and choose static mesh, right? So this static mesh right here is going to be the mesh that's going to change over, like, every time we press it, but it does need a starting condition. So our starting static mesh is going to be a banana, just like that, easy. Then we go to our event graph, and under our events, we need to say that we will be using the interact blueprint again, as per usual. Class settings, implemented interfaces. If you have no idea what I'm doing, then go to previous chapters, because I explained it there. Add, and then interact, BP interaction, there we go. Compile, save, and now we are going to be able to call for interact event interact interface. There we go. So once we call for it, we want our banana to switch to something else, right? So we can set static mesh, right? Set static mesh, with this static mesh being the target, right? And our new mesh can be, well, let's find one. I believe I have downloaded from the Quixel bridge. I have downloaded this blue and red book. So we'll switch a banana into a book. Let's go to not surfaces, 3D assets, and find how that book is called. There we go. Or you can just simply drag and drop it in once you found it in the content browser, like that. So now if we trigger the banana, it's going to change into a book. Let's see if that works or not. Compile, save, let's dock it in there, close the floor blueprint. And here next to this banana, let's actually use our interactive banana, like that. And have it, let's have it float, like so. Press play. Wait for it to, wait for the light to kick in, and we have the floaty boy, and we just we keep missing the floaty boy and it doesn't work. Okay, so the reason why it doesn't work is because it has no collision. So if I were to check the visibility collision, no, that works. Player collision, it has no collision. So the ray does not trigger, right? So player collision doesn't work on this. So to actually have the collision work for the banana, we need to navigate to it, double click on it, right? So it opens up the static mesh for us, or static mesh options for us. Oh, it's not even nanite, so let's make it nanite. Enable nanite support here, apply. That's good. And then we need to actually create, where's the material? There we go. And we actually need to create a collision for it. So remember when we used complex collision as simple for all of the objects in the beginner level course? In this case, we will not be using that. In this case, we will be going into collision here, and we will add, I guess, a box. We can do a box simplified collision for the banana, right? Or capsule. Yeah, probably a capsule, right? And what it's going to do is just going to add a little capsule around our banana. So when it's bouncing around, it's basically bouncing. Like this capsule is the one that's bouncing. That's it. Once that is done, we hit save, we close, and we have our banana with the collision now. So let's play again. Wait for this to kick in, and then take a look at the banana, and there's our foot. This one doesn't change, and this one becomes a book, right? We do need to do the same thing with the book, or actually with any object that we want to use. So with the book, that's going to be pretty simple as well, because our book, well, enable nanite support, apply changes, blah, 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 then go to collision, and a book is basically a box. So we add box simplified collision, hit save, hit close. Now our book works as well. And last one, I'll show. Do we have anything like a little bit more difficult? Okay, I'll show it with a bun. The bun does not have anything very fancy in terms of geometry. We could just use a sphere collision for the bun. But instead I will just show you, because I want to, nanite support, and I will just show you the convex collision, auto convex collision, and just hit apply right here as well in the bottom right. So I believe, yeah, it should now have collision around it, and we will just see if that works or not by just testing. But basically the auto convex collision, it should also show up here. Yeah, it does. There we go. That the whole thing is showing. That's great. It basically will show you the, yeah, there we go. It's going to show you the, or going to create, sorry, a simplified mesh around your shape that is going to approximate the size of the mesh, which is very nice. It does it very well, as you can clearly see. If you want to see the complex collisions, you can choose under show, simple collision and complex collision, both of them to be enabled. Save, close. Now we have book, a banana, and a bun, right? 3 of those. Apologies. So for the book, we already have this set for the banana, or for the bun, and then the banana we need to set it up once again. So we will use multigate. It's gonna be a repetition of what we did, it's looped, of what we did during the material shuffling mode, because it's initially the same process, only that we're shuffling the geometry rather than the material, like that. Last one is going to be banana. Second one is going to be book. There we go. Compile, save, press play. La la la. Book. Wait, why is the bun? Did I mess up? Oh yeah, it's a book again. Bun. My bad. I'm sorry. Let's try again. So I had banana, book, book, banana rather than banana, book, bun, banana. Banana, book, bun, banana. Awesome. The problem right now is that they are not falling down. I want them to be falling down, right? The physics needs to work. So to make physics work, all we need to do is click on the static mesh. And here under simulate physics, we tick mark simulate physics. That's it. Compile, save, press play. There, it's rolling. The banana is rolling, and then we make it into a book, and book is not rolling, bun is not rolling, banana is not rolling, right? So that kind of works. In some cases, you want it to not just be placed, but also to reset the rotation as well as position values. So when we trigger the object blueprint, when we trigger the change event, or what we could do is local offset, add actor or add local offset to the static mesh. And for delta location on the Z axis, we can just say 10 centimeters. So we lift the object up by 10 centimeters every time we change it. And second thing that we can do is set relative transform to the not transform, sorry, set relative rotation. My bad. Set relative rotation to the static mesh, right? Yes, to the static mesh. And the rotation, we basically are saying that, yo, you need to be 0, 0, 0, right? All the time. So every time we change from a banana into a book, the book is going to be not weirdly rotated as banana was, but rather is going to spawn perfectly horizontal. That's what we want. Save. Let's have it just, oops, that's the wrong banana. That's the correct banana. Let's just have it somewhere on the floor. Or maybe at the table. Let's have it on the table. Why not? Come on. Go in here. There we go. Throw down the banana. Something like that. Maybe even rotate it a little bit. And let's press play. Let's just see what happens. So here's our banana. Kinda awkwardly. Oh, actually, no. That one is even worse. This one is on there just fine. And you can see every time I press, the object falls from higher up. Right? So that's quite useful. One last thing is you can enable teleportation rather than movement. So if your object is quite heavy, the movement up will not affect the motion of the object, right? So teleport here for local offset and relative rotation. And I believe that is that. I believe that's it. We have ourselves an object that can transform into any other object, right? So I'm using this example with a freaking banana, but of course you can use this with a chair, right? or use this with a sofa to change it into a different type of a sofa or coffee table or whatever have you, right? So that's that. Great. Last part is going to be sun control. So let's jump right into that. So in terms of sun control, the first thing that you need to do is to create an interface, right? So we want a slider here in the bottom to control the horizontal movement of the sun, and we want a slider here in the top or on the right hand side to control the vertical movement of the sun. So to do so, we go into blueprints as per usual, and I'll just create in this case a widget, what's called a widget, a user interface thing, right? So under user interface we choose widget, oh you can't see, widget blueprint, there we go. So I'll select that, that's the only one that I can select, click it, and I'll call it UI widget. I could also do a small little underscore there. There we go. We double click it and we start editing basically what is it that we want to have in here. So the first thing that you always add, or at least for me, the way I work, is I always add this, where is it? Hello? Where are you? Canvas panel. Canvas panel is a designer friendly panel that allows widgets to be laid out in any location. I like the freedom that this gives me. So I just straight up just drag it onto my UI widget right here, and this panel thus is created. Great. So with this done, I will add two sliders. Slider 1 into canvas panel, slider 2 into canvas panel, or onto canvas panel, and I'll call one slider F2. Select the slider and press F2, and I'll call it H slider, H for horizontal, and another one, F2, I'll call it V slider for vertical, right? And my H slider, I want it here in the bottom, so I select it, and here under anchors, I choose bottom middle anchor right here, like so, right? Bottom middle anchor. So now my horizontal slider is placed there. If I will choose 0 to 0 out the position of it, 0 0, and now you can see it lives right here. Okay, let's fix a few things. First of all, I want it to be actually in the screen, on the screen, rather than below the screen. So if I select it and choose alignment of it to be vertically set to, I believe 1, then it gets pushed onto the screen. That's great. And then for the horizontal alignment, I'll just do 0.5 so that it's right in the middle. Then in terms of my size X or size Y, my size X, I will choose the width of it, and it's gonna be 1000 pixels wide, right? So I anticipate that the screen on which this is going to be played will have at least 1000 pixels in width. I hope so. And then for position Y, I think I will just add like 20, minus 20, just to get a little bit of an offset from the bottom, right? So same thing with the vertical slider. First of all, I will change its orientation to be vertical. Then I will change the anchoring of it to be actually always filling the right hand side. So it's going to be this little option right here, like so. I will zero out the position X, like so. And for the alignment, I will say, I believe it's 0.5 here, no? 1 second, I'm thinking. That's weird, it should fill here. Oh, that's because the offset is so large. So the offset from bottom needs to be 0. Now it's filling, and now you can see that the size, yeah, so that's the X size, the thickness of it. And then our alignment, that's 0.5. It's weird. 1 second. Yeah, so that one needs to be 1. Like that, just like that. Okay. And now I need to figure out why is it. Okay, that's the bottom offset and that's the top offset. Whoa. So for both, I will use 100 pixels to offset from the top and offset from the bottom. And this seems to be fine. This seems to be okay of a slider, right? One thing that I kind of want to fix is the where the sliders are, because they start at 0. I don't want it. So my minimum value for each slider needs to be -1, maximum 1, and the current value is 0. So they're going to be nicely oriented that way. Again, minimum value -1, maximum value 1. Since the value is 0, they're right in the middle, neatly packed. Okay, so this is like a, again, I try for it to be as minimal as possible. So this is the minimal user interface that we're all about, right? Then here in the top right, I press the graph where I actually have these two sliders, and I can see what happens when they change, when you change their values, right? So for each slider, actually I'll get both of them in, and you don't drag them in, you just select them here under variables, H slider, and you choose an event that is called on value changed, right? So if you change the value of the H slider, then something needs to happen. And in this case, we'll just going to go for a print string, right? As per usual, it's going to say hello to us when we change its value, right? We compile, we save, we close for now. So that's our widget. The problem with the apologies. The problem with the widget is that if I now press play, there's no widget, there's no menu. Why is that? Well, that's because we just created the asset, but we're not using it anywhere. So we actually need to call for it. And to call for it, I will just go to my first person character blueprint here, and I will right click and choose a key input. So let's say key pressed, or not key pressed, just key, I guess, keyboard events. And let's just find our, or actually we can just choose any key right here, E for instance. And then once you select it, if you go to the input key option here, you press here, you can choose whatever key on your keyboard that you want to use. So in my case, I will use S for sun, but S is backwards, L for light, L key. So when L key is pressed, it needs to create a widget. Create widget. And the class of the widget needs to be the one that we've made, and I don't remember the name of it, UI widget. Okay. So class is UI widget right here. And the owning player is going to be, I believe, player controller. So this should by default work because we're inside of our first person character, so it should work. Okay, so the owning player should work. If we compile, save, and press the play button, and then if I press the L key, nothing happens. Why is that? Well, that's because when I press the L key, it does create the widget, but it does not show it to us. So what we need to do is we need to add it to viewport. Add to viewport, like that. And the target is the widget that has just been created, like so. Compile, save, press play. L. And now we have our, whatchamacallit, the sliders. we have the sliders. Okay, so with this done, we kind of want to then change up to be able to use the menu, right? And also when we press L again, we want it to turn off the widget, right? So I can say when L is pressed once, it creates. When L is pressed again, it breaks, right? So when L is pressed, we will use flip-flop. This flip-flop tool right here. So first time L is you press the L button, it goes through the A. Second time it goes through the B. First time goes through A. Second time goes through B, and so on, right? So it's flip-flop. So I believe remove from viewport. Nope. Something about viewport. Remove all widgets. There we go. This one right here. Remove all widgets. Right? Should be good enough. Let's try. L, 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 L. Okay, that works. That works just fine. Okay, that's step number one. Step number two is actually getting a mouse in there, right? And not being able to move the camera. So the mouse control is not using the camera, but rather it's using the it's not rotating the camera, but rather it can rotate push the sliders. So we're gonna get to that in just a second. So I'm back. In terms of getting the mouse to show up on the screen, all you need to do is just to get your player controller, which is, you know, the player. Get player controller. There we go. And basically this controller has a bunch of variables, and one of them is called show mouse cursor, and we set it. So set show mouse cursor like that. And when we add the widget to the viewport, we also will tick mark this show the mouse cursor, right? So now it's going to be present to us on the scene. If I compile and play this like that, and we press the L button, now yay, the mouse. But also, what the hell is that, right? The mouse also still controls the screen, right? So it's, we can still see the camera still follows the mouse. So we can't have that. So instead, we need to change the game mode as well. something game mode. Wait. UI. Set input mode. Set input mode. Game and UI. There we go. Sorry, my memory is fried. Yeah, I don't remember anymore. So set input mode, game and UI. There we go. The player controller is exactly the same player controller that we used so far, like that. And everything else we can leave it be. We don't really need to focus in that much. Compile, play. Let's go. L. We have the mouse. As I move the mouse, it does not change. I can still click and drag with the mouse to change the way, you know, the angle at which I'm looking at the world, but besides that, it doesn't change. And look at that. If I change the value, hello, it says hello to me. That's what we wanted to see. One last thing that I'm going to do is I'm going to say, but wait, what one thing? Just 1 second. So yeah, there we go. So when I press L again, the mouse is still there. I need to kill that. So when we press L again, it removes all widgets, but also it needs to show mouse, or sorry, let's get the player controller again. Get player controller, And for show mouse, set show mouse cursor, we untick that, just like so. And then we set input mode game only. And player controller is gonna be the same player controller as what we've used so far. Okay. Something like that. So we have a little bit more functionality in our player. Now, last check. We walk around, yay, all is good. I made the banana bigger, by the way. L says hello to us, that's perfect. We can change the sliders here as well. That's perfect. L. That works just fine. Okay, so with that done, we can now start working on the sun, right? So the sun itself, we can technically, you could change the, where is it? Let's filter through lights, like that. Environment, directional light, there we go. So technically you could just change the angle of the directional light, but I don't think that's such a good idea. I think it's much better to just create a blueprint for the sun and then change the values within that blueprint. I think that is a much better way to do it. So that's what we're gonna do. I will just right click and create a blueprint, which is gonna be an actor, and I'll just call it sun BP, sun blueprint. Open it up, make it smaller like that. And my sun blueprint will have only one object in, add directional light. Directional light, there we go. It's going to complain and say, yo, you're trying to create two suns, you know, one that's already existing and one that's fresh and new. Are you sure? And for now we are sure. Later we'll substitute our original direction light with the new sunlight from here. Okay, as per usual, we borrow the measurements, or not the measurements, I guess, the angles in this case from the scene. So before I do that, I will actually just use Ctrl L to find a nice angle. Something. That's kind of nice, but maybe a little bit. Come on. Come on. Something like that. Something like that seems to be quite nice. Neat and dandy. Alright, so now with the sun, I'll go to my environment light mixer, and here I can see all of the different things that have been changed with it, and actually that's not many things. And even here, selecting directional light and choosing show modified properties, only the strength has been changed to 5 lux. Okay, so let's go to our where's my blueprint? Hello. There it is. To our sun blueprint, and here change the intensity to 5 lux, and then just borrow the angle. Rotation. That's all we need. Compile, save, close, and now all we need to do is just simply delete this directional light that we have, and instead, well, now it's going to take a while for it to recalculate. Actually, I kind of want to force recalculation. 1 second. Reset filters. Is that the skylight that needs to recapture? Yeah, that was the skylight that needed to recapture. Now it's completely black. And now I'll just slap in the sun blueprint, like so. And slowly the skylight should start catching up to it. If it doesn't, that's fine. We can just go into here. Lights. Let me just do that. Skylight, recapture. There we go. It caught it. Why is it real-time capture? Yeah, we tick mark this. That's weird that it wasn't ticked. Real-time capture will solve the problem. All right. So now with this done, we have our blueprint that controls the light, right? Meaning that we can change things inside of it. So let's open it up again. And inside of our sun blueprint, we can say, well, let's get the sunlight, right? And set relative or set world rotation of the light. Set world rotation, right? And every tick, so we're using event tick, is going to check if the world rotation of the light needs to be changed or not. I think this is the easiest way to kind of comprehend. There's more effective ways, but this one is the easiest. And in this case, what we can do is we can say, well, actually the rotation, we don't want to change the rotation just yet. So I'm just going to ask, what is the current get world rotation? What's the current rotation of the light? And just feed it in like that. So it's going to just get these values here, just going to get those and feed them into the world rotation input right here. If I were to press play, the light should, the light stays the way it should be, right? Just going to check one thing. It still gets dark, never mind. And we can play with the banana. Oops. Or a book or a large bun that we can also hit as we walk through it. Where is it? Oh, there it is. Bam. Kick it. Breakdance, banana, book, voila, banana. Oh, okay. Enough with playing around. So we have our sun, yeah? We have the sun that has a blueprint where we check the original position of it and we just say, yeah, set it to the original position. But now what we can do is we can add to that position, and that's a strength of it, right? So I can say plus, or rather before we do that, let's break rotator and let's make rotator. Because we will not mess with the roll. Instead, we will be adding stuff or adding degrees to the pitch, which I believe is the horizontal. And we will be adding degrees to the yaw, which is the horizontal. Wait, vertical and horizontal movement. Pitch is vertical, yaw is horizontal. There we go, like that. How do we transfer the whatchamacallit? 1 second, I'll get there. The slider. How do we transfer the slider information onto here? The sliders are in a completely different blueprint. Well, we will use what's called casting. So here in our widget blueprint, where we basically just have, when we change the sliders value, just print string, we will do something a little bit more, right? So first of all, the sliders value is going to be between -1 and 1 for horizontal slider, right? So we will say, okay, then can you multiply that value by 180 degrees? And it becomes between minus 180 and 180, meaning we can do full 360 degrees horizontally for the sun rotation. And we can say then that we want to cast to the freaking sun blueprint. There's different ways of how to do it. The easiest one, which is also quite expensive in terms of performance, is get all actors of class, and here then we choose sun BP. So what it does, it finds all of the blueprints that are derived from sun blueprint. In our case it's just one, but in other cases it might be more, and then it gives us all of them in a list. And from this list we will just get a copy. We'll just get the first one. Since it's only one sun that we have, it's going to be the only one, right? And then we can access through here all of the variables that we have in our sun blueprint, which we don't right now. Right now we don't have any variables, right? They're empty. So we need to create two. And I'm just going to make one. Just click on this plus sign next to variables for the sun blueprint and choose horizontal or let's go for H sun or H sun, that's fine. H horizontal sun rotation, and choose it to be float number, like that. H sun is float, and create another one and call it V sun, and that is going to be vertical sun rotation, right? And I can just simply drag them in here, get them, and H sun connects to the plus that goes into the yaw, meaning horizontal rotation, and V sun, get V sun, goes into the Y, right? And these guys currently are empty, right? Because they're going to be filled in with the numbers from here. So by default, H sun and V sun, if I compile them, make sure that you compile, both are set to 0, which is perfect for us, right? So now we get the original rotation. So there are like X, Y, Z numbers here, and we don't add anything to them because this is 0, 0, right? And we just show the sun. So this initially does not change anything, but once we start messing with the sliders, then it's gonna change. So to create, or rather to transfer the information, we already have the sun blueprint. I will just, from the get, I will set, this is horizontal slider, so set H sun variable, like that. And that's our variable. And don't forget the trigger, right? It needs to trigger. It's a little bit, actually this is not bad. Something like this works just fine. And that's it. That's our setup, right? I will do the exactly same thing for the V slider. So I select the V slider, click on value changed, like that, crease it, and I will just simply, let's do it quickly. Get all actors of class, sun BP, get a copy, set V sun, this time V sun vertical, right? Something like that. And then for the value, so it goes between -1 and 1. So I can say, I can either multiply or I can do remap numbers, or how is it called? Isn't there a remap? I could swear that there is remap. Or is there only remap here? Wait. There's definitely remap. 1 second. I'm just being stupid. Map, rotator. No, that's trigonometry. I don't care about float, absolute ceiling clamp, division, floor, range. Map range. Okay. So it's not remap. I was thinking in grasshopper terms. It's actually map range. Map range clamped in range A -1, in range B 1, meaning that what we feed in is going to be between these two numbers, right? Like that, the values from the slider. And -1 should become minus, let me just check the current position of the sun. The current rotation, sorry. It's like at 10 degrees. So it should be at like, -1 should be at -30. And B should be at 30, something like that. And let's just feed it in. See if that works or not. Compile, save. Let's play. Let's see. Because this should work, right? Whoa, what was that? Oh, that was the us stepping on the banana. Anyway, L. Drag. Whoa. Well, that's weird. It keeps on building up. Oh, I know what's up with that. Okay, so the problem is that I put the because the problem is that since we're working on event tick, it constantly keeps adding that value to the world rotation, right? So at first tick, it does add that value, but then the second tick, it keeps adding more and more of that value. So we're creating a loop. So you saw that the light was just speeding up, the sunlight was just speeding up. So instead, what we do is at event begin play, I'm just going to grab the directional light and I'm going to say, okay, get world rotation. Get world rotation. And get world rotation, because we keep checking it then, and then it creates a loop. So we only need to check it once. On event begin play, get world rotation, and we need to create a variable that is going to be starting rotation, rotator. There we go. Just drag it in here. Set starting rotation. So that's the starting rotation of the sun, right? So when we begin play, we check what's the rotation of our directional light, and we set this variable, a value that can change, to that, right? And then instead of constantly checking and constantly adding at every tick to that rotation, let's just delete get world rotation from here. Directional light can immediately go to here. Instead, we will just say starting rotation, get starting rotation, and do that. So now let me try to explain this a little bit in a little bit nicer way. We press the play button, so we begin the game, and it immediately checks what's the angle of the sun, and it saves it here, it stores it here. Then we press the menu key, right? And we start messing around with the sliders. So it already has this value stored, right? And it just adds the value from the sliders, from the widget onto the originally stored light. So now this should be neat and dandy. If I press play, press the L button and mess with this. Wow. Wonderful. Okay. Sunlight. Like that. I can see the shadows here messing up. That's fine. I will show you how to fix it. This happens with nanite objects and Unreal Engine, like nanite and ray traced shadows don't work that well, but that's fine. I'll show you how you can fix it. But that's the complete sunset. And you can see that in terms of complete sunset, we're already very close to it. So I'm not sure if I like that. And this is middle of the day. Okay, so middle of the day seems good. That seems like a good angle. But the sunset, or maybe the middle of the day could be even less. So the bottom part of the slider needs to go even more into the minus range, while the top of the slider needs to not do that, right? Needs to be in the plus range. So 1 second, let's go in here. So this minus 30, it can actually be minus 40, but 30 should become like 10 or so. Let's try this again. L. Just lift it immediately. Okay, that's cool, and we get even a little nice, really nice sunset vibe. I keep stepping on that banana though. Okay, so that kind of works, and it works quite well. So I think we can call it. Oh, you don't see the slider, do you? I think we can call it a success, right? Now let's talk about this horror show that's happening here. So to fix the light, this kind of a shadowing bit here, you need to sacrifice a little bit of performance. This is because we are using this nanite technology, and it kind of approximates the shape, but unfortunately with ray traced shadows, it also, like the shadows are approximated on it are really messy. So there are a few ways of how you can fix it. One is ray tracing nanite mode, setting it to 1 might fix. Our ray tracing normal bias, setting that to 1 also might fix it, but in my experience it only fixes it until the next time you run the script or you run the project. So a more permanent fix is actually sacrificing the little bit of the computer resources. So let's say this couch right here, let's go into it. You just simply right click, asset actions, or you can I can show you once with the full on mesh editor look. So here you go to nanite settings and you choose fallback relative error to be 0. Apply changes, save, close. Your couch is now correct, right? And the shading on it is just fine. For everything else, you can just simply select all of these bad boys. Asset actions. So I'm selecting now multiple objects. Asset actions, bulk, edit via property matrix. And here I choose nanite settings, blah, blah, blah. And let's find fallback relative error. This one, the most important one, that needs to be 0. Save that. Save all. Okay, close that. Okay, this didn't get to this one. So as you can see, it's a little bit annoying, but once you do it once, you don't need to do it again. All right. So let me do that again real quick. Relative error 0. Shading's fine, right? So for any object that really messes up with a Control L, come on, give me. There we go. So for any object that messes up your shading, you just simply do that. Go in here. Where is it? 0. Fine. Now it's fine, right? As I said before, universal fix for this. Let's find another one where it's still messy. Maybe we won't be able to. Seems like I cleaned most of them. Maybe outside. Maybe some will be outside. No, it seems to be a-okay. Never mind. So the universal cleanup of this is R, or wait, how is it called? R ray tracing nanite mode 1. R dot ray tracing dot nanite dot mode 1. Like that. Just fixes it. And then there's something else. 1 second. Oh yeah, ray tracing normal bias, setting it to 0, or was it setting it to 2? As you can clearly see, I am very bad with the commands, so I'm not teaching you the command line. In my opinion, it should be all of these should be tools, and we have way too many commands. Okay, press play. Let's try, let's look at the final result of what we have so far. We're running at 50 frames per second, which is acceptable. The couch looks fine, just fine. The banana is doing banana things. Now it's a book. Now it's a candle bulla. And now it's kicked and lives right there. And probably collision messed it up. Then we can L to change the angle as much as we want. Nice. Nice. And that is it. Oh yeah, and we can of course L again, E to change the materials, and E to open or close doors. And do some feet here. I think that this is enough for you to get a sense of how this whole interaction thing works. I don't feel like there's any more variations of tools that architecture visualization would require, at least at intermediate level. Being able to add like other characters that move and that talk with you and so on, that would I would consider that to be advanced. I wouldn't consider, especially for architecture visualization, I wouldn't consider that to be intermediate level stuff. So we'll finish off by talking about how can you package this project into a playable game that you can send to your clients for them to check out, right? So under settings, the first thing that you check, under settings, under project settings, here, under supported hardware, you need to make sure that it's set to desktop maximum, right? Supported platforms, typically I have everything here unticked except for Windows, because that's what we're gonna be packaging for. In terms of packaging, let me just quickly check. Nope, don't need to change anything here. In terms of maps, you do need to choose what is your starting map and the thumbnail and whatnot. So editor startup map, let's just quickly change this. It's gonna be building 1 in my case. Building 1. Thumbnail, for the thumbnail you can choose whatever image you want if you have one. I will just find my paw image if I have it. Yes, I do. Well, that looks bad. The paw image does not look that great. It is what it is, that's fine. For the map, I will use building 1. So that's the map that is going to be ran when the, or wait, sorry. Editor template map. Oh, sorry, the game default map. That's the one that's going to be ran at the start when your client opens up the game. And that is it, I believe. It does ask me to restart the client now. So I am going to be restarting, but before I do that, I will just quickly show you under platforms, under Windows. Now you will be able to choose your packaging type. So it can be shipping, it can be development, or debug game. If you want to kind of package it for the final output, you choose shipping. If it's just for you to check if everything works, it's for development, right? So in my case, I will package it for shipping. So I switched that, and you just simply package the project. I will not be doing that because I need to restart, but you would, right? Then you find a folder where you're gonna save it, click select folder, and it's just going to start like counting and packaging the project for you. It takes a long time, a few hours, maybe even. One last thing is it might give you some errors saying that it can't package and so on. Usually those errors relate to Visual Studio, you not having Visual Studio, or you not having the .NET framework. I'm just writing it here so that you can, it's easier for you to Google what's missing. But basically, if you have .NET framework installed, the correct one, and Visual Studio installed, then there's no reason why you wouldn't be able to package a proper project for your clients. Okay, so I'm going to restart, and I think we're done. We're done. You have already seen the final output of me recording right at the start of the video, so it makes no sense for me to show it again. So I feel like this is the end of the course. I hope you enjoyed it. I hope you've learned something new. If you like this kind of content, leave a like, subscribe, and comment. Tell me, because I'm thinking of mixing things up a little bit in terms of the content. So I just want to get a sense of how many people are interested in this kind of stuff and find use for this. So tell me. Okay, I'll see you in the next one. Later.